Wow, wow.
Hey!
Are we
All right.
on?
I think we're up and
Hello.
running.
Hello.
Hello. Hello.
Yeah.
Yeah.
Okay. Okay.
Deep breath.
Yeah. All right.
Feedback.
There we go. Hi. Good evening, everybody.
Hey, how are you? Hey, how are you?
Put on that
Hey,
face. Put on that face. Yep. Okay. Ready. Hey. How are you? Good evening, everyone, and welcome back to our Sunday night offering of Astronomy Outreach, the Sunday Night Astronomy Show. My name is Chris Kerwin of Astronomy by the Bay. I'm a member of the Royal Astronomical Society of Canada here in St. John. And first of all, I'd like to welcome back our regular co-host, fellow RASC member, Mr. Paul Owen from the Moon Shadow Observatory in beautiful Hampton, NB. Hey, Paul.
hello. Oh, there we go. I was
Hey.
hearing you twice.
Oh, okay.
Yeah.
You don't want to do that. Most people don't want to
Oh,
hear me
yeah.
once.
Twice
No.
as much fun.
And fellow RASC member, Mike Powell from the PFO Observatory from the floating PFO, no, not floating anymore,
Not anymore. Nope.
here in St. John. Welcome, Mike.
It almost floated away.
Okay, we got Chris Larson here from Northern California. Welcome, Chris.
Hey, Chris.
Hello from London, Ontario. Jeff, Robert,
Another Chris.
Mike, Lisa from New Jersey.
Robert.
Jeff. Oh my goodness. I
Ray.
see Ray. I see Robert.
Look at you too in the romper room.
Upper room. Yeah, I remember that.
Yeah.
They never called my name. Never called my name. I waited and waited.
Sure.
Anyway. Okay. Anyway, on tonight's episode of the Sunday Night Astronomy Show. Our sun is a near perfect ball of hot plasma and is by far the most important energy source for life here on Earth. Since we're seeing more activity lately this week, we'll take a closer look. Mike will present the mechanics of what we know about our star. I'll be discussing some of the fascinating new information that we're learning about some current missions that we have exploring our sun. And Paul's going to provide us with the best ways to capture all of that and its effects in images. And we'll also have another interesting Bino Bud target to share. This one is pretty. This one is pretty good. This one is a good one. And we'll also have another wonderful Rosanna's Fun Facts episode to share as well. And I'll have a WhatsApp talk about what's coming up this week, and had a bunch of photos that were submitted here a little bit earlier. So I've got a draw coming up for this book right here, the Night Sky Almanac. And it's an excellent 120-page book on a month-to-month guide to the North American skies from the Royal Astronomical Society of Canada.
There we go.
Very well organized. I really like this book. It's really it's first. Actually, I bought a couple of them, but first time I even looked through it here tonight. But I can see myself sitting down and reading that in my spare time. Yeah, before I retire. Okay, so we're going to take a draw for that a little bit later on. What's that?
I'll be getting that book from you then.
Okay, yeah.
You don't have spare time.
There, yeah. Yeah, you get a lot of spare time, yeah. So sit back and grab your favorite beverage or snack and enjoy. And remember, this is a family-friendly live broadcast. So if you have questions about the night sky or astronomy equipment, we're happy to try and answer them here for you as well. So let's get started with tonight's program. Hello to everybody on both channels here. We're seeing so many people from out of town here joining us as well. Paul's on from the UK. Hey, Paul. San Diego, Harold. Wow,
Hey,
this is great. Keep sharing it out there, folks. We enjoy getting the folks from all around this flat Earth.
Keep them coming.
Okay. Is that the reason for all the technical glitches online? Uh-oh, are there technical glitches online?
I don't know. I don't see any. Facebook's running really well.
But if you are having technical glitches on Facebook, you can switch over to YouTube. YouTube seems to be a solider platform most of the time, so you're welcome to do that. Anyway, we're going to get started here with about our sun. And I'm seeing the words that I'm speaking being transmitted across Facebook too. Are you seeing that, Mike?
Yeah, I was seeing.
Yeah, you must have the CC on.
Yeah,
Turn your CP
I'm
off.
not sure where to find that.
You close cap and right down.
Hmm? It's not coming up on YouTube.
It's the third one over from the microphone. It's the second one over from the microphone, where you turn your microphone off and on.
Okay.
It says CC.
If you turn microphone off and on, and I have don't have camera, and I have raise hand, and PFO presenting. No, it's not coming up on YouTube. They're not seeing it on YouTube.
Okay, I'm seeing it on Facebook.
Yeah, it's Facebook where it's coming up. Anyway, we're gonna have to deal with it. So
Okay.
We'll leave it on not showing here. Thanks for not. Thanks. Good to hear. Thanks for the feedback. Okay, so we're not gonna worry about it. I'm only seeing it.
No, I'm seeing it, but can't see
seeing
it now.
Okay.
I'm blocking the screen with something else.
Okay. Let's go ahead with our topic tonight. The glitches
What was that
behind
again?
us. Yeah, what were we talking about tonight?
Oh, what are we talking about?
And thank you for joining us, everybody. We'll see you next week.
All right. The sun.
I'm gonna go quiet. I'm gonna go quiet now.
That's the one thing I actually spelt right. Sun. So, everybody, it's up all day long, keeps us awake when we're tired, all that good stuff. But what exactly is the sun? Well, it's the most prominent feature in our solar system. It's the largest object. It contains approximately 98% of the total solar system's mass. 109 Earths would be required to fit across the sun's disk, and the interior could hold over 1.3 million Earths. So that's, she's pretty big. So the sun's outer visible layer is called the photosphere and has a temperature of about 6,000 degrees Celsius. I wonder if that would burn your tongue. This layer is a molten appearance due to the turbulent eruptions of the energy at the surface. So what's the sun made of? Well, there's 9 different portions. You got a core, a radiative zone, a convective zone, a photosphere, a chromosphere, a corona. There are sunspots, granules, and prominences. The core. The solar energy is created deep within the core of the sun. It's here that the temperature 15 million degrees Celsius and a pressure of 340 billion times that of Earth's air pressure at sea level is so intense that nuclear reactions take place. This reaction causes 4 photons of hydrogen nuclei to fuse together and form one alpha particle, or helium nucleus. You got fancy words here. So, in the radiative, convective, and the photosphere, the sun has several layers, and I just said them there. The nuclear reactions that occur at the core, about 700 million tons of hydrogen is converted to helium every second. Those numbers are hard to fathom. And since helium is about 7% lighter, this means that 5 million tons of matter per second is converted into pure energy. This energy takes 10 million years to travel from the core to the sun's photosphere, a 500-kilometer thick layer of which most of the sun's radiation and light finally escape. The numbers are just hard to fathom. The chromosphere is above the photosphere. The solar energy passes through this region on its way from the center of the sun. Facula and flares arise in the chromosphere. Facula are bright, luminous hydrogen clouds which form above the region where sunspots are about to form. And flares are bright filaments of hot gas emerging from the sunspot regions. So then we look at sunspots. At sunspot minimum, the magnetic field is relatively straight lines of latitude because the equator rotates faster than the poles, which is called differential rotation. As time goes on, these fields get twisted. During the course of 11 years, the magnetic fields become so twisted and tangled that some of the fields break through the sun's surface, causing sunspots. We see them because they are colder than the rest of the sun. So when we're looking through it with a white light filter and you see the black sunspot, it's actually colder than the surface. The process of tangling is stopped when the system suddenly relaxes to straight lines and the sun's overall magnetic field reverses for the next 11 years. So here is no sunspots at solar minimum and sunspots at solar maximum. And you can see the activity right around the center line there around the equator. And here is a sunspot, which is made up of something called the umbra, the center, the penumbra, which is that outer edge. It almost looks like it's pouring into the center. And then look at, just for comparison, this is one sunspot. They can be larger than the Earth. They're that big. They're huge, massive things, some of them. Granules are regions of the sun where hot solar material come to the solar surface. Granules are about 600 miles or 1,000 kilometers across and only exist for about 5 to 10 minutes before they fade away. It's almost as though the surface of the sun is bubbling like a pot of boiling water. And that is what it looks like when you look at that top. It's just like bubbling soup almost. It's really cool. Here's an animation of a sunspot over 20 minutes. Now, I don't know if you can really capture it because it's not moving barely that much. But what an incredible shot they took for this sunspot. And again, you see the penumbra, the umbra in the center, and then the granulations all around the outside edge. A solar prominence, also known as a filament, is an arc of gas that erupts from the surface of the sun. Prominences can loop hundreds of thousands of miles into space. Prominences are held above the sun's surface by a strong magnetic field that can last for many months. At some time in their existence, most prominences will erupt, spewing enormous amounts of solar material into space. And they are awesome to look at through a dedicated solar scope. And then there's also something called a coronal mass ejection. A CME are violent discharges of material from the sun's outer atmosphere. The ejected material can travel at speeds of up to 1 million miles per hour. If a flow of charged particles and embedded magnetic field collides with the Earth, it could dramatically disrupt the Earth's geomagnetic field and ionosphere. Now, if you remember, I think it was back in, was it 84 or 94 where they lost power on the whole East Coast? That was caused by a coronal mass ejection. So they can really wreak havoc on our system. The Aurora Borealis. When a coronal mass ejection reaches the Earth, it may disrupt the Earth's magnetic sphere, compressing it on the day side and extending it on the night side. This process causes particularly strong aurora in large regions around Earth's magnetic poles. They are known as the Northern Lights, Aurora Borealis, in the Northern Hemisphere, and the Southern Lights, Aurora Australis, in the Southern Hemisphere. Coronal mass ejections, along with solar flares of other origin, can disrupt radio transmissions and cause power outages. Excuse me. There we go. So, the Northern Lights, the bright dancing lights of Aurora, are actually collisions between electronically charged particles from the sun that enter the Earth's atmosphere. The lights are seen above the magnetic poles of the northern and southern hemispheres, known as, again, Aurora Borealis in the north and Aurora Australis in the south. Auroral displays are many colors, although pale green and pink are the most common. Shades of red, yellow, green, blue, and violet have been reported. These lights appear in many forms, from patches or scattered clouds to light streamers, arcs, or rippling curtains that shoot rays of light up into the sky with an eerie glow. And that is our sun.
Awesome,
There we go.
The last person to touch this telescope is in my backyard. Probably underwater right now.
Could be, yeah.
Probably, yeah. Awesome, Mike. Thanks. Yeah, the sun is a pretty amazing object. There's so much happening with it over the last 4.5 billion years, and still, I mean, the only thing that keeps it from blowing itself apart is immense gravity trying to crush it the other way. So
It's hard to squeeze so much information into a small space because
yeah.
there's so much out there about the sun.
Oh yeah.
You're just touching the the tip of the iceberg, so to speak.
Yeah.
Although there'd be no icebergs on the sun.
Well, no,
Yeah.
be hot.
Hey, you never know. Might find them in the future.
You might. Let's hope
You
not.
never know. There's water on Mercury, so
There you go. Okay, Polly. Maybe you can start out with how we can take a look at all this.
Okay. Well, all right. Well, let's just do that. So this afternoon, I'm going to show you a device. I'll show you the picture of the device. I've got the device here, but I'll just show the picture of it. And it's called a Quark, made by Daystar. Daystar is a manufacturer, and Quark is this kind of solar filter that they make, and they make two different models. Actually, they make three models now, but of these devices. And one is for looking at prominences on the sun. The other one is looking at the chromosphere on the sun. But now they have one that actually can do both. So there you go. So I've got some things I want to kind of talk to you about with the sun. So let's see if I can figure out how to share my screen and make this happen. I'm going to hope it'll work on there. So if I share that screen, then I can just throw pictures over on it. So right now you should just be seeing the Harbor Bridge, right?
yeah, nice shot.
Look at all the suns over
Yeah,
there,
yeah.
all over the bridge.
Holy mackerel, look at all the suns. Yeah.
Yeah, where do I want to begin? Okay, well, let's talk about the different ways you can view the sun. All right, let me just open this picture up, and I'm going to put it over here, and this is hopefully how this will work. So this is one way you can view the sun. You can view the sun with a device or a very specific telescope that is designed for showing hydrogen alpha. It's actually a hydrogen alpha telescope, and it shows the bandwidth of hydrogen alpha so that you can look at certain portions of the sun. And I'll show you those portions in a minute. But hydrogen alpha telescope, or this Quark I was telling you about, that which is also hydrogen alpha, that's one way that you can view the sun. Another way you can view the sun is through what they call a white light filter, and that would be this right here. And these are available in a myriad of different ways. You can get them already built with these, with the filters holders already around them so that they'll attach to your telescope, or you can just buy the paper and make your own if you want to. And it's actual solar paper. There are two different kinds of paper, one for observing and one for imaging. So if you're observing, make sure you get the observing stuff, not the imaging stuff, because the imaging stuff allows more through, and it could be damaging to your eyes. So anyway, just a note there. So that way, and then there's also the device I used this afternoon called a Quark, which is another solar filter, and that's that device you see right there. Now on top of that is a little ASI 120 camera, and that is put into this Quark, this hydrogen alpha filter, if you will, and it works on a band or wavelength of 1 angstrom, and you can shift it -7 or plus -0.7 or plus 0.7 of angstroms, so you can try to kind of tune in those prominences a little bit better if you want to. Typically, you can put an eyepiece in that, use it as a viewer through a little 80 millimeter telescope, which is just a little Orion Achromat 80 millimeter. It's all I needed because I'm using a mono camera anyway. So, and then she's using 1 bandwidth of light. So that's all you really need. And they actually suggest if you're going to image anything to use a monochromatic camera, and you'll get better results. So anyway, so that basically is what you see right there. And it's just going through, normally I would have it going straight through, but because I've got the little diagonal there, I don't have to put extensions and stuff on. So it just makes it easier. And I'm just using my little Sky Adventurer star tracker. And anyway, that's what I used today. And I just plugged into my telescope or computer to take some images of the sun. So with the Sky Tracker, all you do if you have one is just put it on the sun mode, and then you're going to track the solar mode. Then you're going to track the sun at its speed at which it moves across the sky. And that's pretty much all you have to do to set that up. So it's really quite easy to do. A while back, back in 2015, that's the Orion 110. and there's the day star quark in there. And I'm going to tell you, looking through that 110 millimeter telescope at the sun with that quark, because what happens with that quark, it only shows a very small portion of the sun, and it's designed to look at prominences. So depending on the size of the chip of your camera and the focal length of your telescope, it'll either be smaller or larger. And the same for eyepieces. If you want to look at the whole disk, you need a really wide eyepiece. If you want to look at something very tiny, then of course you would get a more powerful eyepiece, a very long length eyepiece, if you will. So that's basically how about the quark and the other two ways that you can look at the sun. Now, looking at the sun through a white light filter, when you're actually imaging it, it might look something like this on your computer screen. I'll see if I can play that video. So there is sunspots all over the sun, and there's the granulation Mike was talking about. There's the umbra, which is the dark spot, and of course the penumbra, which is the lighter spot. So that's basically what you would be looking at from a video that you would be taking data from to produce a picture. Once you've got that all done, your image that you can come up with, and I'll show you another image because for some reason I didn't download that image. But here's what you can, what you'll end up with. So you'll end up with something that looks like this, as far as a still. Once you stack it in the software and put it all together, and then once you've got that done, then all you're going to do then is just kind of false color it and make it look like that. So that's kind of how it's done. So you capture it in black and white, you process it so it's nice and clear, and then you just put the false color to it so that you can get what you deem is the color of the sun. In this case, we chose yellow. So that basically is white light. White light will show you the sunspots. It will show you the granulation, and it will show you, I think it's called specula, if I said that right.
Facula.
Did I say that? Specule?
Facula.
Facula?
Facula and specula. Yeah, there's actually two different ones.
Okay.
Anyway,
Spatula.
that would be this stuff.
Spatula.
Spatula. Yeah, all the stuff you see right down here. That sort of white granulation that's kind of running through all of that sort of stuff. So that would be how you would look at it through, excuse me, white light. And there's many different things you can see. So if you're using, say, an 80 millimeter telescope, like I did here, and I'm using, I can't remember the camera I used, to be totally frank, but you can almost get the whole disk of the sun. So again, it's not impossible to get the whole disk. If you prefer to get something a little closer and tighter up, and a longer focal length and a smaller chip, well, that's when you'll end up with, that kind of a view. So, so that's the white light way of doing things. Now let's look at the hydrogen alpha way of doing things. I'll just turn these ones off, so we don't need to see those anymore. So now, when looking at the sun with the, say, either that Coronado Solar Max telescope, this one, you can look at some pretty cool things. This is kind of a result you can get from using that kind of a scope. So you can get something along the lines of this. So if you're looking just looking at prominences on the sun, you can actually tune that telescope so that you're getting more of a prominence look than you are a surface look, because you really want to push the prominences. You can image it, and then you can false color it to make all of these things stand out. And then, of course, you can just label it if you like I did there, and talk a little bit about prominences, as Mike already has. So we don't need to do that. You can also shoot it like this. And I find, and this is why they recommend monochromatic images, because those images where there's no color there that you have to try to balance and play with, and it kind of gets messed and labeled through the contrast of the image, you can't see anything better than what you're seeing right here. So here you get to see the prominences, you get to see the filaments, you get to see virtually everything that the sun has to offer when you shoot it like this and in black and white. So it really does bring out a lot of the detail. And again, this is hydrogen alpha. So this is either that scope or through that little quark eyepiece. And again, your choice of telescope and so on. Here's what it might look like through a quark, and when you're imaging it. And this is a problem. I actually posted this today on my Facebook page. And that actually is the limb of the sun right here. And these are actual prominences coming off the sun. And it's absolutely incredible to see that. And white light filters will not allow you to see this. You have to have hydrogen alpha to be able to pull this off. This was actually shot with a color camera. That's why you're seeing this in color. So, but it's very dramatic. And then when you're done with it, you know, you can make some really cool pictures with that. So basically, you're taking your data, which is the same as when you take pictures of the moon or the planets. You do a live video or you know, an AVI, a film, if you will, and you're going to stack them all together, get the best pictures out of those stacks, and then you're going to end up with an image. So the sun is no different to process than the moon or the planets, really. The other thing I wanted to show you was just a couple of some of the other. Now there's a prominence that is actually coming up, and it's actually going back down again. And that's typically what they do. Usually when you see sunspot, there's two spots on it that some of these gases are released, and then they'll actually loop right back down and go right back into the other side. It's really cool to watch. This is a good illustration of that there, of what you're seeing. And again, this is just on the limb of the sun taken with a quark. Kind of a telescope or eyepiece. When the sun was active, these images that I'm showing you right now, we took these back in 2015. So these have been around for a while. Here's another when the sun was really active back in 2015. The sunspots were just all over the place. This image was actually upside or sideways. That should be typically when you get that much activity, they're closer to the center of the sun and they're going from left to right instead of up to down. And so that one there just placed incorrectly, but I didn't know what I was doing with it. I just want the picture. So, but anyway, that's really a lot of activity, and that is live video of what was going on at that time. And then of course you can turn it into, you can just simply turn it into an image when you're all said and done. And then I can false color that or do whatever I want with it. Another type of device they have out there is called a Herschel solar wedge. And a Herschel solar wedge is another white light kind of a filter, but you actually see it in green. There's actually a major green tint to it, and it uses neutral density filters. There's I think 3 or 4 different neutral density filters that you can choose depending on the degree of brightness that you want. So if you're actually imaging or if you're observing, you can choose the different degrees of brightness so that you can either ignite a sensor or you can, you know, put an eyepiece in and look at it safely with your eyes. But they work very, very well. And this particular, as you can see, there was clouds going by at the time of this particular data was being taken. And let me see, is there anything else I want to show you? Oh yeah, I was out today. I hadn't been out since 2015 with this quark. I said, I got to go out and see if I can make it work. So I took out my mono camera, which I haven't cleaned in probably about the same amount of time. And this was the data I took this afternoon. And there was a huge prominence. Actually, there was 3 huge prominences on the sun today. And this was the one that I caught this afternoon. And it was just absolutely stunning to even, you know, observe, never mind the imaging side of it. And it's just really nice to see this kind of activity. And that's the beautiful thing about the sun is it's a daytime thing. So long as there's no clouds in the sky, you can do it. It's comfortable. You're not fooling around in the dark. It's warmer. But I will tell you, if you're going to image, you need to take a blanket with you because you're going to have to get underneath it so that you're not, so you can see your screen, because you cannot see the screen in the daytime. It's impossible without some kind of coverage. So you'll need to do that. But I'm telling you, it's really worth it if you want to look at those kind of things. So that would be the hydrogen alpha way of looking at the sun. Now, the stacking software that you would use to acquire this would be, or not the stacking software, the software that I used was SharpCap. I think everybody's familiar with that, or most people who are imaging are. And the stacking software, you can either stack it in and put it all together in either RegiStacks, like this one, that's going to open. And I'm not going to go through it. That's a whole other talk. But RegiStacks is where you can use this software where you can stack and align and sharpen and do stuff. Or you can use Auto Stacker, which is the one that I use today. And it's a little more, there's more to it. You can do more with it. And I find it to be a lot more stable. So most people now are using Auto Stacker to do their stacking and whatnot, and just move it over to RegiStacks because they've got a wavelets in there, and you can do some really, really good sharpening of your images in the RegiStacks wavelets. So those are the two softwares, plus SharpCap or Fire Capture. Either of those two will work well. Most of the pros are using Fire Capture, but SharpCap is getting to the point where it does not only live stuff like this, but it's also doing deep sky, live stacking. You can, anyway, that's again another talk for another day. But those are the softwares that I would recommend for this. So other than that, that is my little quick explanation on the sun. Oh, and use webcams or planetary cameras. You're not going to use a camera that can't produce movies, because you need something that produces films, because like your planets or the moon, this is very, very bright, and you're taking very, very short images to the point you're taking sometimes 60 to 120 images a second. So because again, you're dealing with brighter light and that kind of stuff. So the long exposure cameras are not designed for this. You need something that can chirp through those frame rates. So other than that, BD, that's all, folks.
Awesome, Paul.
Cool.
Well, yeah, a lot to it, but still, it's fairly good for a beginner as well to get started on.
Yeah.
And like you say, the stacking software makes all the difference, right? That quark. So I did have a question. There was a question here from Harold. Asked, do you still use a solar filter on the front of your OTA when you've got your quark? I guess.
No, no. The reason being is the time, if you're using like a Solar Max 60, like the one I showed you that was still hydrogen alpha, then there are different things that you're using on that telescope. The design is different, but the quark basically has, it's just like a 4 times teleconverter that's built into it, and it's actually designed to be used at the viewer or the eyepiece end of a telescope. Anything up to 90 millimeter telescope in terms of diameter, you don't need to have an IR cut filter on it. Anything above that, because the heat will start to build in a longer telescope like that Orion 110 I showed you earlier, you have to have an IR cut filter because the heat will build up in it and you can do damage to stuff. So, but as far as putting anything else on the front, nope, leave it wide open. Make sure that if you have a view, a finder scope, that you have it capped or have it off altogether, one or the other, because you don't want to be looking through that at all. Unless you have a white light filter on it that is safe, it's going to stay on there good. Then you can use it for a finder scope to find the sun. But the best way to find the sun is look at the shadow on the ground, make your tube, if it looks like this, it's sideways. If it looks like this, your shadow, then you know you've got the tube as pointed right at the sun, because you're making it as small as you can on the ground.
Right.
The smallest shadow you can make, then you are actually pointing right at the sun.
Right. Good stuff. Thanks, Paul.
Okay.
Okay. Well, then let's keep going. We're into 8:35 now, so I got to talk on the current space missions to look at the sun. I'm going to try to make this brief, but there's a lot to cover because there's still a lot of missions that are looking at the sun at the moment. Let me share my screen first of all. Okay, and we'll see if this comes up. You all good there?
Yes, there.
Okay,
Yep.
So current missions to study our sun. I'm not going to do this really a lot of justice because I got to flip through this fairly quickly, and especially to deal with the one I'm going to talk about at the end here. There's a whole lot. I could do a whole talk on just that one mission. So anyway, excuse me, the missions to study the sun. Well, there's more than 21 space missions that have been successful in studying our star. These include the following, which are still active: the Parker Solar Probe, that's the big one right now. Solar Orbiter, Solar and Heliospheric Observatory, or SOHO, the Advanced Composition Explorer, or ACE, Interface Region Imaging Spectrograph, IRIS, WIND, a spin-stabilized spacecraft, the HINODE, Exploring Magnetic Fields, the Solar Dynamic Observatory, or SDO, and the Solar Terrestrial Relations Observatory, or STEREO. Excuse me. So we'll start with STEREO spacecraft. It was launched back in 2006. The Solar Terrestrial Relations Observatory, or STEREO, has provided scientists a unique and revolutionary view of the Sun-Earth system, composed of two nearly identical observatories, one ahead of the Earth in its orbit and one trailing behind. STEREO has traced the flow of energy and matter from the Sun to the Earth. Now, twin STEREO spacecraft study the structure and evolution of solar storms as they emerge from the Sun. STEREO A still remains active. The twin spacecraft provided the first ever 3D view of the Sun's surface. And in 2012, STEREO captured data on an extreme solar storm more powerful than anything we had seen in the last 150 years. Now, STEREO B's mission actually ended in October 17th, 2018. I'm not sure if they're going to replace that one or not, but it would be nice if they did. The Solar Dynamics Observatory, or SDO, you can go to that website quite often now and catch live images of the Sun. The SDO is designed to help us understand the Sun's influence on Earth and near-Earth space by studying the solar atmosphere on small scales of space and time and in many wavelengths simultaneously. Now, SDO's goal is to understand how the Sun's magnetic field is generated and structured, and how this stored magnetic energy is converted and released into the heliosphere. SDO celebrated 12 years in orbit last week. These spacecraft are just amazing. Like they're expecting to last for a year or two, and they're getting 12 years, 20 years out of them. This mission is still going strong, measuring the beginnings of solar cycle 25, which is what we're into now, with the same data stream as solar cycle 24. Now, some 440 million images are now stored at NASA's Joint Science Operations Center, a repository where students and scientists and you and I can exchange and compare data. This is one of the best places to visit when looking for real-time information about our star, and that's the website there, sdo.gsfc.nasa.gov. Again, I'm going over these very quickly. Excuse me. Now, the HINODE was launched back in 2006. It's still functioning, so we're getting into 15 years on that one. It's an international mission to study our Sun. HINODE explores the magnetic fields of the Sun in order to improve understanding of what powers the solar atmosphere and what drives solar eruptions. Now, HINODE's Solar Optical Telescope is the first spaceborne instrument to measure the strength and direction of the Sun's magnetic field on the Sun's surface, what we call the photosphere. Now, HINODE follows a Sun-synchronous orbit around Earth at an altitude of nearly 650 kilometers. This orbit allows HINODE to observe the Sun continuously for 9 months at a time. HINODE experiences an, quote, eclipse season, during which the Sun is eclipsed by Earth for a maximum of 10 minutes in each 98-minute orbit. HINODE is led by the Japan Aerospace Exploration Agency, or JAXA. The HINODE mission is a collaboration between the space agencies of Japan, the United States, the United Kingdom, and Europe. Now, zipping through space at close to the speed of light, solar energetic particles, or SEPs, are one of the main challenges for the future human spaceflight. Clouds of these tiny solar projectiles can make it to Earth, a 160 million kilometer journey, in under an hour. They can fry sensitive spacecraft electronics and pose serious risks to human astronauts, but their onset is extraordinarily hard to predict, in part because we still don't know exactly where on the Sun they come from. Now, a new study tracing these SEP bursts back to the Sun has provided the first answers. Scientists have divided SEP events into two major types, impulsive and gradual. Now, the impulsive SEP events usually happen after solar flares. The bright flashes on the Sun produced by abrupt magnetic eruptions like this. HINODE has been working with several other sun-watching spacecraft to answer the origin of these SEPs and to understand their part in the ever-changing solar wind. Now, speaking of wind, there's another spacecraft called WIND. It's a spin-stabilized spacecraft launched with a Delta II rocket back on November the 4th of 1994, still functioning. After several orbits through the magnetosphere, WIND was placed in an orbit around the L1 Lagrange point. We'd heard about the Lagrange point now with the James Webb telescope. It was placed there in early 2004 to observe the solar wind that is about to impact the magnetosphere of the Earth. Now, wind was later inserted into a halo orbit about L1 in 2020. Now, wind data has been used directly or indirectly in more than 5,000 scientific publications. So some of these are passive spacecraft. The ones that are more active are the ones we're coming up to. The Interface Region Imaging Spectrograph. They all have acronyms, right? IRIS, this one. So the Interface Region Imaging Spectrograph observes how solar material moves, gathers energy, and heats up as it travels through a little understood region in the sun's lower atmosphere. IRIS is a key part of NASA's sun watching fleet, tracking how material and energy move through this region to help us understand the dynamics of our star. Now, one of the things that IRIS has worked on is this, nano flares. Now, nano flares are small explosions on the sun, but they're very difficult to spot. They're very fast and tiny, meaning that they are very hard to pick out against the bright surface of the sun. Now, IRIS is helping to analyze these nano flares since they may be the reason why our sun's corona is millions of degrees hotter than its surface. Think about that now. The sun's surface is 5,000 degrees, and step a million kilometers away from the sun, and it's now millions of degrees. Moving away from something shouldn't make it hotter. So that's the whole puzzle. And here's a short video of what's been captured. As we look hard at these prominences, and we see these large loops of plasma, we take a look back at these particles, and we can see that some of them are just being picked up here in a second. You'll just barely see them. There they are there. So we believe that these are breaking off and causing the sun's photosphere to heat up that much more, into millions of degrees. We're getting more information though now with the new Parker Solar Probe that's out there. Now, the next mission we can talk about is the Advanced Composition Explorer, or ACE, which launched back in 1998 and still working today. NASA's Advanced Composition Explorer collects and analyzes particles of solar, interplanetary, interstellar, and galactic origins. Now, the data contributes to our understanding of the Sun and its interaction with Earth and the evolution of the solar system. Now, ACE continues to provide space weather reports and warnings of geomagnetic storms that can disrupt communications on Earth and harm astronauts in space, which is very critical for us, of course, right now. The spacecraft have operated far beyond its expected lifetime. Only a couple of years is supposed to last. The spacecraft was designed to study spaceborne energetic particles from the Sun, Earth's L1 Lagrange point. That point again, about 870,000 miles or 1.4 million kilometers away from Earth. Now, continues to provide near real-time 24/7 coverage of solar wind parameters and to measure solar energetic particle intensities. Okay, so now we get into SOHO, one of the more popular spacecraft, I would say, studying the Sun. The Solar and Heliospheric Observatory, which was launched back in 1995. SOHO, the Solar and Heliospheric Observatory, is a project of international collaboration between ESA and NASA to study the Sun from its deep core to the outer corona and the solar wind. SOHO was designed to answer the following three fundamental questions about the Sun. What is the structure and dynamics of the solar interior? Excuse me. Why does the solar corona exist at all? And how is it heated to extremely high temperatures of about 1 million degrees C? And where is the solar wind produced, and how is it accelerated? Now, that's the website that you might want to go to learn more about that particular spacecraft. Again, I'm only touching the surface on these things. Solar Orbiter is another mission which was launched just recently, not in 2020. Now, it's a joint mission between ESA and NASA to collect data that will help answer a central question of heliophysics. How does the Sun create and control the constantly changing space environment throughout the solar system? So there's so much study going on. With Solar Orbiter, now for new sun-watching spacecraft, the first solar eruption is always very special. That's what was captured here. On February 12th of 2021, a little more than a year from its launch, the Solar Orbiter caught this site of a coronal mass ejection, or a CME. This view is from the mission's SOLO High instrument, short for Solar Orbiter Heliospheric Imager, which watches the solar wind, dust, and cosmic rays that fill the space between the sun and the planets. It's a brief, grainy view. Solar Orbiter's remote sensing didn't enter full science mode until November. Now, it used one of its 4 detectors at less than 15% of its normal cadence to reduce the amount of data acquired. Still, a keen eye can spot the sudden blast of particles, the CME escaping the sun, which is off camera and up to the upper right. The CME starts about halfway through the video as a bright burst, and then the dense leading edge of the CME and drifts off the screen to the left. Now, Parker Solar Probe. This is the big one that's making all the news. NASA's Parker Solar Probe is studying our star from closer than any other spacecraft. On December the 14th, 2021, NASA announced that Parker had flown through the sun's upper atmosphere, the corona, and had sampled particles and magnetic fields there. This marked the first time in history that a spacecraft had actually touched the sun. Parker Solar Probe is designed to swoop to within 4 million miles or 6.5 million kilometers of the sun's surface to trace the flow of energy, to study the heating of the solar corona, and to explore what accelerates the solar wind. The spacecraft is like Webb. It deserves a longer discussion at a later date, which I hope to bring to you. For now, you can check that link. One other interesting point, though, after it launched from Earth in 2018, it skimmed the sun's scorching atmosphere and used the sun's gravity to reach 528,000 kilometers per hour, or 146 kilometers per second, the fastest spacecraft ever. As Parker Solar Probe passed through the corona on Encounter 9, the spacecraft flew through structures called coronal streamers, like this. These structures can be seen as bright features moving upward in the upper images and angled downward in the lower ones. Such a view is only possible because the spacecraft flew above and below the streamers inside the corona. Until now, streamers had only been seen from afar. They are visible from Earth only during a total solar eclipse. I'm not going to spend any time here because we're getting too far into our discussion, but this is some of the information, this is some of the things that are going to be happening in the future with Parker Solar. Again, another whole discussion on that one by itself. And here's the images that were revealed as it was, quote, touching the sun. There's our Milky Way going by. Here's the planets going by, Mercury, Venus, and Earth. And all that, those particles that you're seeing going by, that's the solar wind. Though they focus on the star at the center of our solar system, 3 of NASA's sun-watching spacecraft also have captured unique views of the planets. Now, using instruments that look not at the sun itself, but at the constant outflow of solar material from the sun, the missions ESA's and NASA's Solar Orbiter, NASA's Parker Solar Probe, and the Solar Terrestrial Relations Observatory have sent home images from their distinct vantage points across the inner solar system. So this one comes from the Solar Orbiter back in November of 2020. We have Venus here, Earth, and Mars. So they're not just staring at the sun, they are looking at the solar wind, and the planets get in the way. Another one here from the Solar and Terrestrial Relations Observatory saw most of the solar system's planet in just one image on June the 7th of 2020. And thirdly, also part of the thing that is being discovered is the number of comets. This is actually a comet sliding into the sun. That was Comet Ison. Not Parker Solar Probe, but SDO has observed over 2,000 comets in its lifetime. And we've also had SDO able to image the Venus transit back in 2012. Here's another image come from Parker Solar Probe. So we have Mars, Saturn, Jupiter, Venus, Earth, and Mercury. Not a bad collection for one set of images on one spacecraft. And this is the most recent picture, the surface of Venus from the Parker Solar Probe. On February 9th, 2022, NASA released this image from the Parker Solar Probe, which it took during a flyby of Venus. It's the first ever visible light image of the surface of Venus. And many more exciting discoveries are on their way. So, lots to see. And I'll stop presenting.
That's pretty hot stuff.
You waited for 20 minutes to say that, didn't you?
Yeah.
It could be like we're not. She's as cool.
I was simmering for 20 minutes.
There you go. I mean, you can't do justice on the talking that in 15 minutes. It's just
No, this
there's
stuff.
so much. Yeah.
Yeah.
Maybe we'll break it down in future weeks. Maybe I'll talk of just one mission. But anyway, let's carry on because we're into some time here. So how would we head up with the Binal Bud next?
I will shove this over here.
At the end of your talk, Mike, maybe you could tell us who discovered this Binal Bud target.
Yeah, that'd be good.
Maybe. That'd be an interesting question, actually.
Yeah.
So all the Binal Buds that we've gone through, and all the Binal Buds I've talked about and compared things to, binocular target of the week this week by Binal Bud is the moon. We haven't once said, look at the moon. We've compared everything to the moon, but we've never actually said, point your binoculars at the moon since Binal Bud started. And guess what? Uh-oh. I forgot my keys.
Oh, well.
Checking every pocket. Yeah. Oh, no. Anyway, I couldn't resist that one. It was kind of funny. So, the moon is Earth's only natural satellite. At about 1/4 the diameter of the Earth, compared to, say, the width of Australia, it's the largest natural satellite in the solar system relative to the size of a major planet. It's the 5th largest satellite in the solar system overall and larger than any known dwarf planet. Now, here comes the big question, and I'll let you figure this one out on your own. But how do I find it? Well, if it's out right now and it's cloudy, you won't see anything. But I will challenge you to get up at 5:30 and look almost just a little bit past due south. And I guarantee you won't miss the moon if it's clear. So that's how you find it. You look up and see the moon. But good time if you want. Looking to the south will be around 5:30 this morning. And take your phone with you and get a picture of it. What will I see? Well, it'll look something like this, right? What will I actually see? Okay. Well, waning gibbous on February 21st has illumination of only 76%, right? This is the percentage of the moon that's illuminated by the sun. The illumination is consistently changing and can vary up to 10% per day. But on February 21st, the moon will only be 19.57 days old at 5:30 in the morning. Now, through a pair of 10x50 binoculars, this should be your view. Now, it's pretty good size. I mean, everybody looks at the moon, but 10x50s, it's actually an easy target to spot. You'll see lots of stuff. Compared to the full moon, okay, it won't be quite full, so it might be a little bit more than half of a full moon. That being said, the moon being our target, here's proof that we were there. Now, this might be a little bit slow because he's running on the moon here. Walking on the moon, and Buddy opens the door. Crap. There's our Binal Bud target of the week.
That's almost like cheating. It's like, when you've run out of Binal Bud targets, here's what you bring up.
Well, it's funny. I looked at everything and I went, something? I talk about, we compare everything to the moon, but I haven't actually said, look at the moon.
Absolutely. So, you're right.
There we go.
Oh, that is so funny.
Thanks, Mike. Okay. How big is it compared to the moon? Okay. Paul, would you like to bring up Rosanna's fun fact for us?
I'm trying.
Okay. I'm trying.
Okay. Give me a second.
We're going to be a little long here tonight, folks, as you can probably understand. We're running about, 8:56.
Okay.
Yeah, we're going to be 20 minutes. Okay.
We'll be what we'll be.
That's it. What will be, will be. Okay, Sarah.
Right.
Yes, Sarah.
All right. So this is this week's.
There we go.
Rosanna's Fun Fact.
Hey!
Hey. Hello, Rosanna. Welcome back for another one of her absolutely wonderful fun facts. And actually, somebody had a question a little earlier on. I think her name was, see if I can find it, Christa. Christa asked, do you ever hear about the rocket that's going to slam into the moon? Well, anyway, we talked about that last week, and I think there might be a little more information on this week. So you stay tuned into this, Christa. Okay, so Rosanna writes this week, hi, Paul. Everyone makes mistakes. Most of us, when we make a serious snafu, hope no one is around to catch it. However, Bill Gray, developer of Pluto's project software and featured in last week's fun fact, has actually made a bit of a blunder. An email on Saturday from John Giorgini, an engineer at NASA's Jet Propulsion Lab, changed the story, stating that it is not a SpaceX rocket that's going to hit the moon on March the 4th. He found that the orbit was incompatible with the trajectory that the Discovery took and collected Bill. So, like most of us, Bill's initial reaction was, well, I'm pretty sure that I got it right. Nobody likes to be wrong, and certainly not wrong in the global arena. Long story short, it turns out that the item that is going to wallop the far side of the moon is the Long March 3C rocket that launched China's Chang'e 5 T1 spacecraft on October 23rd in 2014. Now that spacecraft swung around the moon and headed back to Earth, dropping off a small return capsule that landed in Mongolia. Now let me just see if I can make this work. There we go. So here was the collision course. So part of the rocket is expected to crash into the far side of the moon on March the 4th. Initially thought to be a SpaceX rocket stage, the object may actually be part of the rocket, of course, that we just talked about. So below, and here's the picture of the outline of the orbit of the 3C rocket. Now that's not up and down, but I think you can see that even at that angle. That's fine. So notice the wording may actually be, which might make one suspect that no one is 100% sure of what is going to smuck the moon, or at least slightly hesitant in making a prediction. The purpose of determining which item of space junk is going to make contacts makes for an interesting read. So you can go here, and then she left a link to a site you can read. I tried to look at it, but I went into all kinds of ads and commercial stuff. If the New York Times block you out, let me know, and I can help with that. Okay, but let's travel on to what I really want to talk about and the fun fact for this week. This was a smorgasbord week, so space-wise, and so I had to really restrain myself from creating pages on many topics. So the exciting news is the James Webb Telescope has sent back its first images. Although many news sources cover this, I found the explanation of the LPay Science in Tech Newsletter to be the best. It says, excuse me, the James Webb Space Telescope has begun the laborious process of calibration and has already transmitted its first image. I'm going to show you this. There we go. Its first image. Well, in actual fact, its first 1,560 images, because that was the number of photos needed to determine the state of the 18 hexagonal mirrors that make up the main mirror. Now, the positioning of the 18 reflectors is not yet perfect. The tremors from its launch and the thermal contractions due to its progressive reduction in temperature have caused each reflector to point slightly out of line with the rest of them. So they now will move on by one in order to create a single surface that is perfect as possible. So for now, the Webb is not functioning like a single telescope, but rather 18 different ones, each of them sending its own image. Now, to start the calibration process, the telescope first focuses on a bright star that cannot be confused with others around it. And for this task, the rather prosaically named HD 84406, which is a star, has been chosen. It is located in Ursa Major and in an area that is short on bright stars. So as was expected, the first photos taken from the telescope showed not 1, but 18 points of light. The same star, but seen from all the 18 different mirrors. The telescope took hundreds of photos to determine where HD 84406 was, over an area not much bigger than the size of the full moon. Luckily, the images were closely grouped together, which says a lot about the quality of the telescope's structure, given that it resisted the vibrations and acceleration of launch very, very well. Now, let me get this. Now, the next step involved identifying which image corresponded to which reflector. One by one, the technicians inclined each mirror by nanometers to discover that only 1 point that had moved in a new photo. The identification took several hours. Now it's clear which image matches which reflector. So based on this information, the next step consists of adjusting the positions of each mirror with microscopic movements. To do so, actuators, you have to see in the photo, and you can look at that a little later, that can move in steps that are 10,000 times smaller than the diameter of a human hair are used. So they do so without any lubrication and at temperatures of minus 230 degrees Celsius. That's an amazing feat from every perspective. They do this using, precision motors and gears that at first glance do not look particularly special. The secret lies in the very rigid H-shaped titanium part and other part that presses its central bar. As a result, the two lateral supports flex imperceptibly, and that movement of just a few nanometers is transmitted to the mirror to get it into position. Of course, one of the first images that sent back was a selfie, the James Webb being truly a telescope that's representative of the times. It took its own selfie. In case you were wondering about that one bright spot, it is the one camera about out of 18 that was actually pointing at the star. So every day we are presented with fascinating news about space, from space about our Earth and all its wonders and mysteries. Some of the info can be misinterpreted, mistakes happen, or things can just look different depending on how you look at them. Now, here's an interesting thing. Here's a photo, not photoshopped, I received this week. If the showing off by the young guy made you shudder, then just look below.
Yeah.
This is the same rock, but from a different perspective. So I just wish something out there could capture whatever crashes into the moon on March 4th with any perspective. Whoops, didn't see that coming. So that is absolutely amazing and interesting, and that is this week's
Rosanna's Fun Fact.
Hey!
Oh, that is absolutely amazing.
Awesome.
Another amazing fun fact.
Two interesting things to keep an eye on for sure.
Yeah, so I hope that Christa, I think her name is Christa, that answered your question as to did you hear what was going to be happening? I think we just did, and hopefully, like Rosanna says, that we are correct.
Awesome. Yep. All right. Thanks, Rosanna, once again, for another interesting fun fact. Love them. Every week, they're great. Okay, I'm going to do real quick what's up, because we still have some photos to go through. If I can find it here, just bear with me. I'm not going to bring that one up. It's going to be, I thought I had it opened. I might have to hold off.
Next slide.
Next slide. It wasn't that presentation. I thought I did open it. That's not nice. Where'd it go? Uh-oh. Maybe I don't have it. Well, we might have to hold till next week. Or I might have to hold till a night this week. Goodness gracious. Why does this always...
Great balls of fire.
Oh, there it is. Okay, hang on. Ooh, hey, there it is. Hey. Okay, hey, there it is. 6 screens to look at and trying to find one file. Okay, I think we can go from here. Now, let me share my screen first of all. Okay, not too much going on, so we can cover this pretty quickly, I think. Oh. So what's up this week? Okay, well, let's get started. Okay, Friday, February 18th to Monday, February 28th. I guess the next 2 weeks is Zodiacal Light. For the next 2 weeks, look to the west after sunset for the faint pyramid of light known as the Zodiacal Light. You'll need dark skies to get the best view. Now, the Zodiacal Light has been thought to be caused by dust from the many comets and asteroids that have passed through the solar system. It is true that that's part of it is, but recent studies have actually suggested that it may also be caused by dust storms on Mars. Imagine that. So it's in the west after sunset in the spring, and it's in the east before sunrise in the fall. So you need a really dark sky to pick that up, but that nice big cone that we see here of light here, scattered dust in the solar system. Okay, all week long, Venus, Mars, and Mercury, of course, in our morning sky. The bright planet Venus, reddish Mars, and little Mercury adorn our morning sky all week long. All perfect targets for binoculars. Little Mercury will disappear from our view soon, so catch it now because it's not going to be there. I think by the end of next week, it's disappeared, but it's going to be replaced by something else. Now, Tuesday, the moon occults the double star Zubin al-Janubi. I just like saying that one. Zubin al-Janubi, Zubin al-Janubi. On the west coast only, though. On Tuesday, our waning gibbous moon will occult the double star Zubin al-Janubi. This occultation is only visible from North America, Western North America. Zubin al-Janubi is a spectroscopic binary star. It's a type of binary star in which it's not possible to visually separate the two stars. Now, the two stars cannot be distinguished by using any telescope either. There's nothing to say that there can't be more stars that can be distinguished visually, but then it wouldn't be classed as a binary. The only way that they know that it can be identified as that is by looking at the spectrum of the stars and the Doppler shifts. So one star moves in front of the other, basically. The distance between us and that star would cause a Doppler shift, and that's why we know that it happens a couple of times. So we believe it's two stars, but could be more.
Wouldn't that be apostrophe S, Zubin al-Janubis?
It could be, yeah, but I think that wouldn't rhyme very well. Zubin al-Janubi, Zubin al-Janubi, Zubin al-Janubi. That's a good jazz tune. Okay, the third quarter moon rise February 23rd, Wednesday. The third or last quarter moon is also called a half moon because the sun's rays illuminate exactly 50% of the moon's surface. Half of the moon's surface is always illuminated by direct sunlight, except during a lunar eclipse when Earth casts its shadow on the moon. Now, just how much of that light we can see from Earth varies every day, and that's why we call it a moon phase. It's a wonderful time to follow along that terminator line, that line that separates day and night of the moon. Features always appear more pronounced along that line. This phase also means that our moon will be up during the day, which is always pretty. Nice to see that nice moon up there this morning. Thursday.
30.
Yeah. Thursday, February 24th, our moon visits Antares, the red star Antares. Look south on Wednesday morning to view the waning crescent moon as it visits the red giant star Antares in Scorpius. Now, Antares is the brightest star in Scorpius, and it's about 550 light years from Earth. Antares is an M1 red supergiant star, cooler than our sun, yet it appears very bright to us. That's because of its size. In fact, if you could hold our sun and Antares side by side, Antares would be more than 11,000 times brighter and 680 times the diameter of our sun. No fooling around there. On Saturday, our morning moon joins the morning planets. So there's going to be a nice view. Our waning crescent moon over here. I kind of made it bigger so we could see it. But we have Venus, Mars, and Mercury lined up. Next Saturday, watch the morning sky before sunrise as our crescent moon joins the morning planet show of Mercury, Mars, and Venus. And Venus is pretty hard to mistake that one. Venus, Mars, and our moon on Sunday. This is going to be the best view all week right here. Next Sunday presents a nice group of celestial events to enjoy. This view of brilliant Venus, reddish Mars, joined by a slim crescent moon. A perfect photo op, but of course also a perfect naked eye view. So that's southeast, looking southeast at 6:30 a.m., about an hour before sunrise. On Monday, though, next week, I brought up Monday because I know we're only Sunday to Sunday, but we'll try this one anyway. Mercury, Venus, Mars, and Saturn now in our morning sky. So we've got 4 planets, soon to be 5. Look to the southeast before sunrise next Monday to witness the ring beauty Saturn return to our morning sky at a magnitude 0.8. And competing with the looming sunrise, Saturn will be very difficult to pick out, but it will soon replace Mercury as a 3rd morning planet to enjoy. So Mercury is dropping because it's already past its farthest west in the sky that it can be over here. So now its orbit's going to take it back this way and drop down towards the sun again. It only takes 88 days to go around the sun. Saturn just beginning to appear in our morning sky. It's going to keep climbing higher and higher until we come up to a nice conjunction between Saturn and Mars coming up in a little while. Okay, and from there, we've also got Saturn and Mercury coming up on March the 1st. Okay, this is a ways away, but March the 1st and over the following few days, Saturn and Mercury will be offering a celestial dance as they switch positions. Saturn replaces Mercury to become the new morning planet. So Saturn will get higher, Mercury will get lower, and they'll be a little bit closer here, right around the end of the month, of this month. And of course, don't forget, still lots to enjoy in our winter time sky. We still got Orion up there in our southern sky, really nice and high now. We have the winter circle here, made up of all these stars and all of the constellations that reside in these in this winter circle part of the sky, or winter football, you want to call it, winter triangle, whatever. Here's Perseus with a double cluster. There's lots in here to the Orion Nebula. We've got Taurus and the Pleiades star cluster. All kinds of things to still view. And here comes my favorite. Yay! And what's behind Leo? Virgo. And what's between Leo and Virgo? The Virgo supercluster. Hey, galaxy season is right around the corner. Isn't it, Paul? Yeah. Okay.
Yep.
So that's about all we're going to talk about this week on the show.
Now that is the perfect attitude of a cat right there.
Yeah, it is. Yeah. Cats always have that attitude. Okay. So let's stop presenting there. And Chris says your guys are covering astronomy from Aldebaran to Zubin al-Janubi. Hey, that's A to Z. Good point. Okay. Sharing one more time because we got some photos here to share. And then we're going to wrap it up for the evening. And I just need to get the photo folder open, and I got to be sure that they pop up properly. First of all, I got to get my notes open. Just 1 second here. I am prepared, but I just have so many things on the go. Okay, that should be notes over here. I think. Okay. Bear with me. Sorry, folks. Just 1 second here. Stop.
By the way, Montreal won 2 games in a row. First time this year.
No, really?
Unbelievable.
Is that football?
Yeah. No, anyway, so
Okay.
Yay.
Yay.
My goodness, what's going on here? I can't get to my folder. I gotta stop sharing for a second.
Next slide.
Next slide, yeah. Let me get my windows open here properly first. There's one, that one there, and this one should be right here. No, not there. It's gonna go. Here it comes.
Oh, is he pull a wrap?
Yeah. Okay, let me try sharing again. Here we go. There really are 6 screens. It really isn't that easy. Okay, first up. This one should come up. Okay, we got a photo here from David Samard. David says the moon today with the same with equipment, Ioptron mount and a 60 millimeter solar telescope, and next image 5.
Okay, that would
Solar,
be,
yeah.
if it's a solar scope, it wouldn't be that.
No,
Wouldn't be the moon.
the 60 millimeter telescope. He's got solar in there, so it would be the
Okay.
60 millimeter telescope. And next image 5, yeah.
No, nice shot.
Awesome,
Oh,
yeah.
very nice. Yeah, terrific.
And here's a sun shot.
There it is.
Yeah, with the Ioptron
There you
solar
go.
solar scope. There we go.
There's lots of little dots on the sun.
Yeah.
Not very big though.
No, yeah, they're not today for some reason, but still lots, I guess.
Yes, granulation.
Got this one from Kathy Adams. Kathy sent this one in. Hi, Chris. 2 moon shots this week. The first is just hours before the full moon on the 15th, and the second was on the 18th. Kathy takes some amazing photos.
Yeah.
And both were once again fast shots as clouds moved in right after I shot them, she said, always. Both single shots, ISO 100, 1/100th of a second with my Celestron 6SE and the Sony A6000.
Nice.
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 Still hoping for clear skies or somewhere up there, she says. Okay.
They're coming.
And they're coming, yeah. And another here. She says, just a few more spots. I'm waiting to see if the that area that caused that big explosion earlier in the week there that rotates around to us. I'm really interested to see what happens with that as well.
Yeah.
And once again, here come the clouds, he says. So she's only getting moments to get out there and get set up.
In the clouds.
Very nice.
Corinne Maria Ann McDonald sent this one in. She says, hi, Chris. This photo was taken early morning, February 16th, prior to the snow moon peak. Also was taken at the Irving Nature Park.
Beautiful.
Recognize
Beautiful.
that spot. Beautiful spot. Great shot. Thanks, Corinne.
That's the spot that the walkout is, isn't it?
Yes, yes.
Yeah.
Matthew Dupre sent this one in. These couple of the good old moon, he says.
Oh, nice.
Yes.
Yeah,
Very
nice,
nice.
eh?
Yes,
Well
sir.
done. Well
That
done.
does nice color on the moon.
Yep.
We've got another one here from Kathy with the moon and the trees.
Oh, I love that.
Nice.
Look at the clouds. That's
Mm.
nice.
She can do some amazing photos.
Yeah.
From here, we're going to go to. I did ask for some photos. Everybody knows that, I guess, earlier today, because that was my limit right there. When Kathy's photo, that was only 9 photos. So I was saying, well, maybe put a request out there for a few more. So I did, and it got flooded. That's great. I love getting the reactions. So we got Jeremy Costain sent these ones in. This is from Turtle Creek area. He said February 17th, just with camera phone shots.
Oh, sweet.
Oh, yeah.
Nice, eh? And then he's sent this one in from Alma, summer 2021. He said with camera phone. Nice moon over there.
Look at that.
Yeah.
Yes, sir. The Great Pumpkin.
Yeah.
I was thinking.
Yeah. Jason Dane sent this one in. Sundog at Grand Prairie, Nova Scotia this week.
Nice shot.
There she is, the
Yeah.
Sundogs. Yeah.
Yeah.
Lots of ice crystals in the air that time for sure. Thanks, Jason. Joni Bird sent this one in, taken in Central Blissville, New Brunswick, last February. My teen was holding the flashlight.
That's cool.
That's cool.
Nice
That's
shot.
very cool.
Yeah.
Yeah.
Good job. And we got this one from Ashley Spring.
Oh, beautiful.
Nice reflection. Beautiful.
Kennebecasis, looking towards Minister's face, she says. So
Really?
I know what that is.
I
Yeah.
can't believe that calm out there.
Yeah. Yeah.
It's beautiful.
Incredible. Kim Houlihan sent this one in, full moon over St. John.
Oh, we know where
Nice
she is.
capture. Yeah.
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 Well done.
It's a beautiful spot to take shots of that city. Oh,
Yeah, isn't it? This one came from Shelley Armstrong, sunset out in Rossay area.
I took a picture of that very stand this afternoon.
Did you? Is that right?
Testing that new camera extender.
We were out there. We were out there setting up one night, weren't we?
yeah,
Yeah.
we
Yeah,
got
we
up
did.
there and did a little
Many years ago.
Many years ago. Yeah. Well, it seems like a lifetime ago, doesn't it? Yeah,
In fact, it was when Trudy first got her Dobsonian.
I think
I
it
think
was.
so.
Yes.
Yeah.
Denise Gauthier sent these ones in from Beldoon. Sunrise shadows, he says, from
That's
Beldoon.
cool.
There you go.
Neat.
It's a cool shot.
I love it.
Another Beldoon sunrise.
Oh, look at the snow. Oof.
Yeah. Yeah.
Wow.
And February 20th, Celestron telescope, Samsung Zoom. Nice shot.
Got the moon, yeah.
Indeed.
MJ Banks sent these in. St. Andrews, December the 2019, he says.
That's beautiful down there. Isn't it?
Nice. Yeah, it's a beautiful spot. And shot from the St. John River in July 2018.
Nice.
Yeah.
Nothing like a nice water shot.
Oh, I'm telling you.
Now, Robert sent this one in. Cassiopeia constellation area, taken with the Canon T7i at ISO 800. 50 millimeter lens, f2.5, 2-minute exposure. with a
Not bad.
Skywatcher Star Adventure Pro. Yeah, you can see the
Very
ET
nice.
cluster and the Pac-Man Nebula, NGC 7822, and CED 214 top right as well. I can just scroll in there. Yeah. Oh, there he is. That's ET.
Nice shot.
Is he that far over? Or is he this
No.
far over? No, he's over here, isn't he?
I'd have to reorient my head here.
The W? I thought he was right in here.
That's it right there.
Right
Right
there.
here?
Yeah, that's
Yeah.
ET right
There he is, yeah. ET. Awesome,
All right.
Robert.
Nice.
Nice shot.
Thank you. Okay, next up we have Christa Irving. Moonrise from Charlotte, New Brunswick, looking towards
Oh.
Mount St. Joseph in Carleton, Quebec. Not nice.
Wow.
That's incredible.
Gorgeous.
And she's got a sunset shot from Charlotte. Say
And
that
hair.
fast 5 times, yeah. Yeah,
Look at the colors.
nice, huh?
Yeah, gorgeous.
Jamie Phillips sent this one into the moon. Thank you, Jamie.
Yes, there.
Oh, look
Looks
at that.
cold there too.
Yeah, it does.
96.
It's cold everywhere. We got this one from Lisa. Lisa and Fanning says she reprocessed this photo from an ISS pass under the moon from February the 9th. The equipment she used was an iPhone 11 on a tripod. So using the iOS app, ISS Spotter, I was able to determine when the ISS would be passing over our house. Visibility began from the northwest at 5:45, traveling to the southeast. This gave me time to set up in my front yard, knowing it would pass horizontally over our home and under the moon. As I was capturing the video, an airplane can be seen traveling vertically,
There you go.
which made for an which made for an intersection when stacked. 53 images were extracted from video and stacked in Starry Night Sky Stacker for iOS. I then cropped the image so that the pitch of the roof made for an interesting composition. It sure did.
There you go.
Almost
Nice shot.
trying to try
Very
and get
nice,
that.
yeah.
Beautiful.
Well done. And now all you need is about 3 or 4 Starlink satellites in that shot.
Yeah.
No, we don't. These come from Hayden. This one is the ISS, and he's captured another view of it here,
That's
Oh,
cool.
very nice.
and some airplane trails.
Yes,
That's pretty
sir.
cool. Don't see them
Oh,
very often.
cool.
Yeah.
I think they're neat. I really do. I think they're awesome.
Thanks, Hayden. Rob Fanning sent this one in. Sunset at Sandy Hook, New Jersey. Nice capture.
Beautiful. Sunset.
Mm,
I'm assuming he's facing east or west, rather.
I hope so.
Unless
Emma,
this is sunrise, then he'd be facing east.
yeah, that's true. Well, you didn't say sunset. Emma McPhee sent this one in. Full moon this week, and a plane taking off at the Moncton Airport. Cool.
Oh, nice.
Fly me to the moon.
Yeah.
Ooh.
Can't say that too loud. I'll get copyrighted. Harold Locke sent this one in. Harold
Nice
says,
Nice.
no fancy landscape astrophotography here, he says. The other night I was having a nasty time seeing through my light pollution, and it was past my usual viewing time. I took one last look at the moon before closing down, saw the moon, went and grabbed my tripod and camera and had to take a shot. Now got out late toward the celestial dome. Light pollution wiped out stars below 30 degrees above the horizon. Waited for the moon to rise around 45 degrees. Used the Celestron 127 MCT Canon T7 2000D. Exposure 1/60th of a second. ISO 100. Mounted prime focus. Tonight's moon was 94% illuminated. Waning gibbous. Harold, you're going to have to come to the East Coast and see us at a star party. Come on up to Mount Carleton.
Absolutely.
Yeah.
We'll show you what the sky's like 35 degrees and below to the horizon.
Yeah.
There's a lot of stars there. Yeah. We'll feel for you for sure. Thanks for sending that in, though. Joy Ryan sent this one in. Sunset Murray Corner, Provincial Park, July 5th of
Nice.
2018.
Gorgeous.
And Ian Bloom sent this one in. One of my favorites, he says, of Eta Carina, taken with my 115 millimeter Sky Rover triplet using a modified 700D Canon. Now, where do you get Eta Carina, guys? Taken
Because
in my
that's southern, it's the southern
yeah,
target.
taken in my
Where's he from?
taken in my backyard observatory in Ravenswood, Victoria, Australia.
Australia.
Wow.
Yeah.
Yeah.
Awesome.
Beautiful.
Oh, what's going on here? Resume.
Beautiful shot.
So I was singing those notes, and I get a notice up that my video was being blocked. That's how bad it's getting. So Facebook, I think you're still there. Hopefully you're still there.
Yeah, it is. Yeah.
We're
Okay.
still up.
No, actually, no, it's dropped right out.
No, I got you.
No, it's still there.
Okay, I'm only seeing 2 viewers live at the moment.
Well, I got you on Facebook. It's all normal.
Yeah, I see it. Maybe it's just us too.
Maybe that's the government watching us.
I'll look at YouTube.
Okay, hang on for a minute. We're just going to make sure that Facebook is still up because we do have a draw here to do in a minute.
You're still up. I see you perfect.
Yeah.
I don't see any viewers online.
Okay, but I do.
It says
Someone typed in hello.
Oh, they did. Okay. I'm not seeing any comments yet on. Okay, are we still up?
We're about to find out.
Okay, hang on there, folks, on YouTube, please, just for a minute.
Oh, post has been removed.
The post has been removed.
Yeah.
The video is removed.
Wow. Someone typed
No.
in hello.
No, you're still live on YouTube.
Still having YouTube, yeah.
Yeah.
Isn't that something?
Facebook police got us.
Wouldn't you think
Yeah.
that was pretty ridiculous?
Continue on.
Don't sing a song.
No, won't say a word.
Carry
Okay.
on as though you were normal.
Okay, sorry about that, folks. We'll carry on here with YouTube, I guess. Hopefully those who are over on Facebook will switch over. Nobody sing any notes? Okay,
No, thanks.
I think we're done with our photos anyway. That's unbelievable. And that was all of our photos, yes. So I'm going to close out that. I apologize for everybody out on Facebook. I had no idea that was going to happen. Okay, sorry about that, folks. That's just ridiculous. Okay. Can you imagine that? Okay, let's do our contest draw anyway. Because if it's somebody off of Facebook, I'll let them know.
Okay.
Wow, I can't believe that happened. Of all the things, yeah. You sing a 50-year-old song or more. Anyway, I got all the names in here in my little basket again from the draw. Everybody who sent in a photo. Somebody says I'm still on Facebook. Okay, perfect, Jeff. Good to hear. Maybe it still is up. I do see that it's still running on my end. I'm still, but it hasn't. I don't know. We'll see. Maybe some other folks will comment back and let us know. So no singing, no nothing else. Okay, let's take a draw for the contest for that book, the 2022
Okay.
Night Sky Almanac, the 120-page book. Actually, it's quite a nice book. So let quickly. I'll just flip through it here. Lots of star maps. Flips through all the different months. The special events coming up each month are listed there. There's a really nice map of the moon here in the center. Not in the center, well, in the front. And it talks about telescopes, binoculars. It's a really well put together book. I bought a few books like this, not quite this one, but one similar to this. And if I had known that this was available, I would have bought this one instead. But it is put out by the Royal Astronomical Society of Canada. And it's authored by Nicole Mortellero. Mortellero, okay. So anyway, let's do our draw for this book. Nice, handy little book.
You can see us on Facebook again, by the way. So.
Oh, they can. Okay, good. Good to hear. All right.
All right.
Drum roll.
All right.
And the winner of the book is going to be Robert Cadet. Hey, Robert.
Congratulations, Robert.
Congratulations, Robert.
There we go.
Robert.
Well, I'll be in touch, sir, and how to get the book to you. Awesome. And thank you, everybody, for entering those pictures. That was great. Nice to have a great big reel of photos like that to be able to show off. So I appreciate all your help with that. And who knows, we may have another contest again soon. Thumbs up for that.
Yeah.
Okay. So in closing then, I guess tonight, sorry about the eventful evening. No singing. I'd like to thank you once again for your continued support out there, and a special thanks to Rosanna for another wonderful Fun Facts episode as well. Thank you, Rosanna, for all the work you put in. We really do appreciate it. Remember, too, we do love getting your photos, so send them into Sunday Night Astronomy Show at gmail.com, or just put them on my Facebook page, and we'll be happy to include them on our next broadcast. We're also looking for topics for suggestions for future shows, so let us know, too, if you have anything that you'd like us to talk about in a future episode. I have got a few ideas. We did talk about a few ideas here coming up, so if you have anything to talk about or we'd like us to talk about, let us know and send it to the same address. And please let your family and friends know as well that we are here every Sunday night at the same time. Well, we're here at least on half the audience. My apologies to help educate you and entertain you a bit on the night sky. So for now then, from Mike and Paul and I, stay safe, everybody. We wish you all clear skies, and we hope to see you again here next week. And remember, as we like to say, keep your scopes.
Oh, yeah.
Point it up. Thanks, everybody. Have a great week.